All right. The numbers are different, but in essence, it's the same problem. I've got two masses there, and the question is, where does the other mass go so that it's in equilibrium? So conceptually, what do you know about gravitational forces? This is a gravitational force problem. Someone go for it. Tell me something.
Pulls objects towards each other?
Yeah, that's the key thing right there. So if I take my third object, if I put it here, what's the direction of the force on the red dot in relation to this? Which way is it? Okay. What about in relation to the 16 kilogram?
Still.
It's attracted to both of them. If it's over here,
Same thing, but just the opposite direction.
yeah. All right, so on the outsides here, it is going to be pulled one way or the other. It cannot be in equilibrium because there's no way I can balance those forces that are in the same direction to add them up to get zero. So it has to be somewhere in between. Now, where exactly it is, I don't know. I'm gonna label that X. So I know it's going to be pulled towards the 7 kilogram, and it's going to be 70 kilograms and pulled towards the 16 kilogram. Let's see, I think this was 1, 2. So 1, 2, 3. So this would be the force on 3 from 1, and this is the force on on 3 from 2.
Did you just put it in the middle just because we just don't know where it is exactly?
Oh, I do know it's in between them, somewhere.
Yeah. But
So-
you just put it on one, does that matter?
No, I generically, it's at some distance X. Odds are it won't be an integer. So, I can look at this two ways. There's the strict adherence to the math, and then there is the conceptual approach to the math. I know that if it's an equilibrium, those two forces are going to add up to 0. So the pull to the left has to equal to the pull to the right. So I can write it as F31. The magnitude of that is equal to the magnitude of F32. So it's big G, mass 3, mass 1, over the distance squared. Got to be equal to G, mass 3, mass 2. So over the distance between them, squared. Now, I've seen some students faced with this, with just pulling in numbers at this point. Sure, if that's what you're into. However, we can simplify things a great deal by canceling out, yeah, right there. By canceling out common factors. So what's going to be common between them? What can I get rid of?
The big G and then mass 3.
Yep. So it does not matter what this mass is. When I wrote this up, I almost just wrote this as 15 gajillion. The mass of this is irrelevant. So what I'm left with is M1 over that distance R13 squared is equal to M2 over R32 squared. Well, R13 I just said is X. So this is M1 over X squared is equal to M2 over, well, I know the distance from here to here is 6. Because that's at -2 and that's at 4. So that distance there is 6. So this distance here from the 16 kilogram to the third mass has got to be the difference between the total distance and X. In other words, 6 minus X.
So where did the x squared come from under M1?
The generalized gravitational formula it's the distance squared.
It's in the,
And
We're
then
just
the
trying to
x
find
comes
this.
from the fact that I said that distance there is x.
okay. And now does that x go from -2 to 4 or just to 1?
That x goes from -2 to wherever this is.
Okay.
And that's what I'm trying to find. Where am I gonna place that? And I probably should not have used x. See, can I make another letter out of that quickly enough? Yeah, put a little double strike through that. And the reason I'm doing that, hopefully will become clear later if you don't see it right now. All right, so now I know what mass 1 is, I know mass 2. I have only one unknown, I have one equation, it's solvable. The question is, how do you want to solve it? So how do you want to solve it? Let's make the assumption that you want to solve it. How would you do it?
Can you just cross multiply?
Yep, okay, that's one way. So I've got M1 times x minus, 6 minus x squared is equal to M2 x squared. I don't know why I put x in parentheses, but I did anyway. Now what? We're solving for x.
I would just do the parentheses. I would just make it 36 and minus x squared.
And then you would realize that's not the right approach. What is a minus b squared?
One? Or is
No.
that
Doesn't it have the 2AB in the middle?
Yes, it does.
Because you're doing the string.
A squared minus 2ab plus b squared. Now, if you don't remember how to do that, a minus b times a minus b, FOIL, you get the a squared. Outer, you get negative ab. Inner, you get negative ba. And at the end, positive b squared. And so that's your negative 2ab. So this becomes M1 times 36 minus 12x plus x squared equals M2x squared. 36 M1 minus 12 M1x plus M1x squared equals M2x squared. At this point, I'm going to stick the numbers in. So M1 was 70.
Mhm.
Minus 12 times 70, x plus 70, x squared is equal to 16, x squared. Somebody's going to tell me what those are. Oh, this one I might be able to do. Negative 840x plus, let's combine those, 54x squared. And this is
2,520.
we now have a quadratic form, or I guess standard form. Put a more traditional 54x squared minus 840x plus 2520 equals 0. So x equals 840 plus or minus the square root of 840 squared plus minus 4 times 54 times 2520 divided by 2 times 54. You will get two answers. One of which is correct, one of which is not. But let's get both answers and then talk about what the difference is. Oh, and again, this is my double bar x.
Could you not just write x subscript 1?
Yeah, that probably would have made more sense. I started down this path. All right, we have an answer.
I got 11.496-ish. 6. The 3 isn't there. Yeah.
And?
Yeah, 4.059.
4.059.
59.
All right. Which is easy, the correct answer. And what does the other one mean?
Well, my first thought is that both of them are above 4, and we said it should be between -2 and 4.
It's the second one because X just told you the distance between -2 and wherever the thing is. It didn't tell you to start at 0.
Right. You're definitely not, that's why I did the double x there, because that, what we just solved for is not this x. So we found this value right here. The distance from -2. So the first one, or the first solution puts us at, over here somewhere, at 9.496 on my number line. And the second one puts me about here at 2.054, 059. Which is the correct answer?
2.05.
Why?
Because it's in where the X is.
It puts the mass in between the other two masses. All right. What's happening here? Why was this a solution?
An outer pool?
An outer point?
Yeah, like an outer plate was pulling outwards.
No, I mean, when I'm over in this region, it's being pulled to the left by both masses. Think about my formula here, the way I wrote it. I have two magnitudes of forces that are equal to each other.
Would it be that if it's there, then never mind. I'm lost after where you got the 2.059 and the 9.
Oh, where I got those?
Yeah.
All right, what we found right there,
Yes.
so in my number line, I have a number line here, and I have one mass at -2, the other mass is at 4 on my number line. I defined this double X as the distance from the -2. So these numbers right here is where it actually is on the number line. So -2 plus that and plus that.
Okay, so you just did, okay.
Yeah, I should, that's why I should not have used X, because I got two different X's here. And if I had been thinking like Jack, I would have done X sub 1 instead of this double X. All right,
Is it that 2 is in equilibrium when it's there?
yeah, this is the correct answer right here. This is when the magnitudes of the two forces are in opposite directions at equal magnitude, keep it in equilibrium. And over here, the magnitudes are the same also. But what's different between this spot and that spot?
That spot is where it's in equilibrium.
Yes,
So you got that correct?
Would it,
say it again.
Because it's the gravitational force, and that's what you're trying,
We are working with the gravitational force. That's not different from between this spot and that spot.
would it, make the 16 kilogram the middle one, and that would make it in equilibrium?
No.
We
All right.
could,
Spoiler. This is the point of it's in equilibrium, it's being pulled that way.
Oh, okay.
Equal magnitude of force. Over here, it is equal magnitude of force except they're both in the same direction. So there are two places where the magnitude of the forces are the same. Only one of which are the forces in the opposite directions. In one of the places, they're in the same direction. Now, there is a simpler way. If I'd been thinking, I would have chosen not 70, but 64. I know it's gotta be in the middle. We talked about that earlier. That's the place where it's gonna be pulled in two directions, and we have a possibility of the total force being 0. I know that it's gotta be closer to the 16 kilograms than the 70 kilograms, because this has a greater mass, therefore it would naturally have a greater pull from the same distance. So I have to be closer to the smaller mass for it to be in equilibrium. Mathematically, at this point, or the previous point, instead of squaring the binomial, I could just take the square root of both sides. And I get the square root of m1 times 6 minus x is equal to the square root of m2 times x. So I get the square root of m1 times 6, now let's stick the 6 up front, minus x square root of m1 is equal to x square root of m2. Get the x's together, 6 square root of m1 is equal to x square root of m2 plus x square root of m1, which is x square root of m2 plus square root of m1. So x equals 6 square root of m1 over the sum of the square roots, which is 6 square root of 70 divided by square root of 70 plus square root of 16. And it feels like it's somewhere around 4. I'm just assuming there's not a Carol's error there. So the square root of 70 is quickly 8, so I have 6 times 8 divided by 8 plus 4, so 12. Yeah, okay. Feeling good. With this solution, With this technique, it is a whole lot simpler mathematically. However, one, you have to be in the right region. Two, the first way we did it, where we had 6 minus x squared, if we had gotten it backwards and written x minus 6 squared, we would have still gotten the same two answers. But with this technique, it would give you different answers. You've done 6 minus x, I think you would have ended up with the 11. So, you need to make sure you're in the right spot, you define things properly if you want to do it the simpler mathematical way. Questions? Yes?
No.
Oh, great. Any questions on this? All right, don't forget to test on Wednesday, and enjoy the rejoicing.
What chapter is it on?
4, 5, 6.
Say cheese.
I don't think people would notice.